right. Thank you so much, everyone, for attending today's presentation. So as you can see, I'll be presenting about human-centric design, integrating evidence-based design to enhance health and well-being in built environment. So I just wanted to start with a little bit of introduction about myself. I'm Nasrin Golshany. I'm a faculty member at Department of Family and Consumer Sciences. I've been teaching in the area of interior design and architecture for more than 10 years, I would say. So I started as a teaching assistant during my master in Iran. And then I also work as an adjunct professor at Islamic University at Neyshabur. And then I joined University of Oregon. During my PhD, I was also working as a teaching fellow. And before joining CSUN, I also work as an assistant professor at California State University at Fresno. And I also have been teaching at CSUN since 2024 in interior design program. I've been teaching different courses. And regarding my background, I'm coming from architectural background. So I did my bachelor in architecture. I also received my master's degree in landscape architecture. And again, my PhD was also focusing on architecture. So I received my PhD from University of Oregon. And during my PhD, I was working on different projects specifically related to evidence-based healthcare design and sustainability design projects. So during these times, I also have been working as a professional architect and designer. So before coming to US, I was also a licensed architect in Iran. So I was working on different types of projects, mainly residential and healthcare projects. And then after coming to US, I also have worked with different companies as a researcher and also designer that you can see a couple of them, Salazar Architect and also HKS Office. So basically, the main topic that we are going to discuss today, which is the environmental psychology, it has a very huge overlap with my research background and research activities. So my research activities in general includes different topics related to environmental psychology, evidence-based healthcare design, and in particular, I have a very strong scholarly interest in the intersection between people, building, and environment, and how these different components are interacting with each other to provide a healthier environment for the users. So my aim as a scientist and designer at the same time is to improve the designer's decisions making with regards to the human being health and well-being. So in this process, we are usually following an evidence-based design approach. So evidence-based design is the process of basing decisions about the built environment on credible research to achieve the best possible outcome. So as you can see in this slide, these are the different steps of evidence-based design approach. So we usually starting by defining the objective of the project. And then after that, the pre-design phase, which is focusing on collecting the evidences, critically interpreting them, and then developing the design solutions or the concepts based on these evidences, and then developing the hypothesis, collecting the baseline, and after the construction, we have the post-occupancy evaluation. And in most of the classes that I'm teaching, I also advocate to this evidence-based design approach, meaning that in most of the classes, the students are following a kind of like hands-on experience. They start with collecting data, looking to scholarly evidences, and they developing their design solutions based on these evidences. And then at the end of the class, by constructing their prototypes, they actually testing their hypothesis. So when we're talking about evidence-based healthcare design, we are basically talking about this very comprehensive system, which is the human-centric design. And as you can see, at the center of the system, we have the human being. So human-centered design is based on physical and psychological needs of the human users, which enable the users to function at the highest level of possibility. So here you can see that this system has an overlapping of different variables, which are including ecology, empathy, health, demographic, culture, environment. So any variable related to the users of the environment needs to be taken into consideration. And then at the same time, we are focusing on humans' outcomes. So this is not just a designer style, this is a design process. This could consider as a design driver, which respond to the needs of the users. And it basically, by utilizing the research findings, will respond to different outcomes and different needs of the users, that how the built environment can impact their performance, their well-being, their comfort, and at the same time, how it can impact the indoor environmental quality. So again, how the built environment, the human being, and the surrounding environment are interacting with each other. So that was a kind of like introduction about the definition of evidence-based healthcare design and human-centric design. And with that introduction, I'm going to walk you through different research projects that we have been conducting during the past few years. And through these projects, we are going to learn more about the process of evidence-based design and how the built environment and different variables of indoor environment can impact the health and well-being and different outcomes of the users. So the first project that I'm going to talk about is this project, the impact of human-centric lighting parameters on older adults' perception and cognitive performance. So this is basically my primarily area of focus, which is basically lighting design and especially aging population. And this project that I'm going to share about is a part of my dissertation that I did during my PhD. So as you may know, aging population is growing really fast. And by 2040, 1 in every 5 Americans is going to be over the age of 65. And among this vulnerable population, cognitive impairment is one of the significant problems that they are dealing with. And this is not just about the cognitive impairment, they are dealing with a lot of other issues. They are suffering from sleep disorder, behavioral disorders. They are suffering from stress, agitations, falls, injuries. And this is exactly the time that they are forced to move to assisted living facilities. And if we take a look at the literature, especially this study that was conducted by NES, which was a comprehensive literature review, different indoor environmental qualities such as air quality, thermal environment, acoustic, lighting, and also non-light visual factors, they all are contributing to different outcomes of the users, especially the cognitive performance. And as you can see, among these variables, lighting can play a very significant role. So the way that the light can impact our cognition and cognitive performance is through two different pathways. So the first one is through the non-visual pathway, which is basically through the suprachiasmatic nucleus in our hypothalamus. And then from there, it can impact the melatonin and can regulate the circadian rhythm. And at the same time, light can also impact the cognitive performance through the visual pathway, the way that the light can impact the retina right behind our eye. And then from there, the visual information can be gathered and transferred to different areas of our brain, and consequently can impact the perception and consequently the cognitive performance. So if you take a look at the literature in the area of lighting design and how it can impact the cognitive, there are a lot of studies showing that the light level, the intensity of the light, and also the temporal pattern, which is basically the duration and timing of the light, they both can contribute to the cognitive performance. However, when it comes to the light spectrum, which is more related to the CCT, to chromacity, to the light color, and also the spatial pattern, which is about the distribution of the light or the positioning of the light, there are not that much of evidence in the literature. And that was exactly the gap that we found. And the main research question that we wanted to answer was to see how spatial pattern of light or the positioning of the light and also the spectrum of light, especially the CCT or correlated color temperature, can impact the perception, the preference, and the cognitive performance of aging population. So in order to answer this question, we created this research framework. We conducted 3 different experiments. And the first experiment was focusing on a survey. The second experiment was a kind of comparison between virtual reality and real environment. And then the final experiment was, again, within the virtual reality that we wanted to see how these variables are impacting the cognitive performance. So these are basically some images from the first experiment. So in this step, we used a method which is called picture content analysis. And based on this method, we developed different indoor environmental conditions based on different positioning of the light through the literature. So we created these 6 different patterns of light, and we basically showcased these patterns through some surveys. And we asked the participants, who were 60 participants, 39 female and 29 male. And we asked them to basically rate their preference, mood, and perception through forced choice questions and also Q-sort questions. In the second experiment, what we did, we actually wanted to see if there is any difference in terms of the cognitive performance and also the perception of older adults between virtual reality and actual real environments. So we designed this test, which is the trail making test. This is a well-known cognitive test. And we conducted the test both in an actual environment, and we also designed the same test in a virtual reality. And we had a within subject design. We had 32 participants, and we asked them to complete the cognitive task and also at the same time responding to this self-reported survey, basically rating their perception and perceptual outcomes. And then the last experiment was this 2x2 factorial design that we had 2 levels of CCT, 2 levels of color temperature, and also 2 levels of a spatial pattern, which you can see here in this picture. So at the top, we have the spatial pattern 2, which is more complex. It is non-uniform, peripheral, direct, and indirect. And at the bottom, you can see the existing condition in assisted living facility, which is basically a very uniform, central, and direct kind of composition. And we, again, asked them to complete the same trail making test and also respond to the self-reported subjective perceptual surveys. So looking at the findings, we found that the aging population prefer uniform lighting over non-uniform lighting and indirect lighting over direct lighting. That was one of the main findings of the first experiment. We also found that older adults perceive non-uniform lighting as a more relaxed environment, while uniform lighting reinforced a sense of formal setting associated with higher stress level. Here in this slide, you can see one of the participants who is doing the cognitive test, the virtual reality environment. So the finding of the second experiment showed that the rating of visual comfort, pleasantness, and cognitive performance were similar. So there was no significant difference between virtual reality and actual environment, while participants experienced higher level of stress in the virtual reality environment, which was based on the widgets which were collecting the self-reported outcomes. So in terms of the main question of the study, we found that when it comes to the visual performance, the most visually appealing pattern was the non-uniform, peripheral, direct, and indirect, meaning having more complexity in the pattern. is more suitable or more pleasant for the users with having a lower CCT, meaning a more yellowish color. But on the other hand, when it comes to the non-visually outcomes, which is exactly the cognitive performance, having the same complex pattern, non-uniform, peripheral, direct, and indirect, with higher level of CCT, which is more bluish color, is more efficient. So altogether, based on the finding of the study, that different CCT and different spatial pattern have different impacts on older adults, having a tunable and also a layering lighting design in the environment could be the best and the beneficial type of lighting design, especially for the aging population, meaning that the light could be more cooler and more direct in the morning and while they are doing their daily task, right? And then it can get warmer and indirect in the afternoon when they are getting ready for the sleep. So having a combination of different intensities and different colors would be the most efficient type of lighting design, specifically for aging population. So that was the first study. And the second project that I'm going to talk about was this collaboration between HKS Office, which is a well-known architectural firm, and I was working with them as a researcher with the Center of Brain Health. And in this study, we actually wanted to see how the indoor environmental qualities in office spaces can impact the productivity and especially the brain health of the users or the employees of the office. So as I said, we work with the Center of Brain Health, and they created this very comprehensive framework focusing on strategic attention, integrated reasoning, and innovation. And based on these three different metrics, we had a think tank session with the employees of the office, and we asked them to provide design solutions that can be implemented into the office environment. And we came up to these three different ideas. The first one was the brain break room or the focus room. The second one was an innovation lab. And the third one was a social break area. So these environments or these facilities and rooms, they were provided for the users in different floors of the office. And they were also notified about these environments. Another layer of the data that we collected was indoor environmental qualities. So we measured these indoor environmental qualities by putting these Omni sensors that you probably can see here in this table. And we basically collected these IEQ variables such as temperature, illuminance, air quality, and acoustic. And at the same time, we also asked the participants to complete the health and productivity survey. And we also had behavioral observation and mapping, meaning that we were walking in the office and we were looking at their behavior and the way that they are using the environment. So based on the finding of this study, we found that multitasking has a negative correlation with these different outcomes, such as brain breaks, task planning, work experience satisfaction, and connectedness to the office. And we also found that 43% of the employees, they reported they are frequently multitasking. Among the IEQ variable, we also found that acoustic is the leading environmental factor related to the peak performance, meaning that if they are having a very quiet space, it can improve their peak performance. So the third project that I'm going to talk about is this project, which was a collaboration between Salazar Architect in Portland, Oregon, and also Energy Trust of Oregon. So in this project, we were working on affordable housing, and we basically focused on two specific case studies that was constructed by Salazar Architect, and we wanted to see how different design strategies can improve the visual and thermal comfort of the users. So we specifically focus in these four variables: the height of the units, the shading, layout, and color. And then we used a simulation software, which is called IESVE. And we did simulation based on different daylighting and also different variables related to the thermal. So you can see some of the results of the analysis between these different scenarios to see which variable is more impactful and can improve different visual and thermal comfort outcomes. So among different variables, we've found that increasing the height from 9 feet to 10 feet is the most efficient type of a strategy. And after that, the color, like changing the color of the indoor surfaces, which is basically related to the light reflectance values, which is an indicator of like how much light different surfaces are reflecting. And these are the two most successful design strategies. And when it comes to the selection, definitely the most cost-effective strategy was changing the color. And then after that, shading and layout, we're staying in the second and the third level. So another project, which I was just a part of the project, was this collaboration between High Performance Environment Lab at University of Oregon and also Energy Trust of Oregon. So in this project, we wanted to see how net zero schools are performing around the US. So it was a very comprehensive study. These were the three main questions that we answered. What are the net zero schools' impact on building performance and the environment? What are the net zero schools' impact on occupants and building operation? What are the successful strategies and design process for net zero schools? So we have different set of data. We started with a comparative case study. We also had surveys, data mining. We had interviews with the stakeholders, which were including the basically designers of this project and also the administration team. Also, we conducted a lot of energy simulation and analysis. So here in this slide, you can see some of the analysis in terms of like different indicators. For example, as you can see, we had 7 different schools. So if I go back, you can see here their exact locations all around the US, and most of them are located in Oregon, some of them located in East Part. And we basically compared different indicators such as energy prediction, daylight glare probability, which is an indicator of their performance of the building in terms of the energy saving. Also, acoustical condition, the impact on neighborhoods, property value, increasing neighborhood walkability, percentage of time in indoor comfort zone, classroom daylight performance, and also annual solar exposure. So these are some of the variables that we compared between these different schools to see which strategies are the most successful ones. So between different strategies, these are the most successful strategies that we found as a more common pattern: integrated participatory design, engaging stakeholders, embracing passive systems, setting up proper metrics, and shoebox performance simulation, meaning that having a very rough sketchy model of the project at the beginning to see how it is performing in terms of the energy efficiency, and also the feedback loop, which is the iterative design, like receiving feedback and modifying different design strategies. This is also another project, the Sage Glazing Harmony, which is a glazing company. So we had a collaboration with this company to see how different type of glazing are performing in terms of the visual and thermal comfort. So they were basically developing a new product, which is the second one, Sage Harmony, which has a kind of tinted gradual color on this type of glazing. And we wanted to see how all these different type of glazing are performing in terms of visual and thermal comfort. So the way that we conducted this study, we used these testing cells within the company. So we had 4 different rooms, and within each room, we collected the data in terms of the visual comfort. So we gathered information through these data loggers that we installed in the room, and we measured illuminance, Also, we captured HDRI images to see how it changed the luminance ratio, the daylight glare probability, and also the contrast threshold area. And in terms of the thermal comfort, we measured the temperature, relative humidity, and air speed to see which one is performing better. So here you can see these 4 different type of glazing. So when it comes to the visual and thermal comfort, we found that the sage glazing harmony, which is the first option, which has this kind of tinted glazing, was the most efficient one. When it comes to equivalent melanopic lux, which is an indicator of like how efficient is in like each designer strategy in terms of like providing a healthier light, which can regulate the circadian rhythm. We also found that the sage glazing harmony was the most efficient one. And when it comes to the daylight glare probability, we found that the second strategy, the sage classic, was the most efficient type of glazing. And the last project that I want to talk about is still an ongoing research project, collaboration between the ARC Center and Los Angeles Department of Water and Power. And in this project, which is called Connect, we want to see how different indoor environmental qualities are impacting the comfort, satisfaction, productivity, and collaboration of office employees in LADWP Work Hub. So this Work Hub that you can see in these pictures is a new developed kind of facility in their office. It's located in the 6th floor of their main office in downtown Los Angeles. And we wanted to see how IEQ factors are impacting the employees' health, well-being, and performance. So in terms of the method, we have designed this framework. So in the first phase, we conducted a comprehensive literature review, and we mainly focus in these 5 categories of IAQ variables: the thermal environment, light, noise, indoor air quality, and also non-visual factors. In the second phase, we conducted both surveys and also observational data collection. And then the third phase that we are still developing the method is developing an adaptive work hub model, which is basically compatible and can be used for other type of facilities as well. So here you can see a summary of the research method. So as I mentioned, we started with the literature review. We reviewed around 589 academic studies from more than 30 key sources, focusing on 9 IEQ factors, which were linked to 5 employees' outcomes. And then the second part, we conducted a self-reported survey. So we developed a workplace environmental and social performance questionnaire designed in Qualtrics, and we basically sent this to the employees of the office. A total of 98 employees aged between 18 to 65, they participated in the study. And 93 participants provided valid responses, which were included in the analysis. And then the third step, which was the behavior analysis, we developed a centered behavioral and environmental mapping. And we basically asked the research assistants to attend to the office employees and conduct this behavioral analysis by filling out this survey on Qualtrics. And we collected a total of 278 observation intervals, which were completed. And then among these 272 valid recorded, and they were continued to be analyzed in the next phase. So here you can see some of the findings of this study. And so in terms of the comparison between the work hub users and non-work hub users, we found that the work hub users reported significantly higher satisfaction with overall workspace quality and in most of the environmental features, such as layout, acoustic, lighting, air quality, furniture, while perception of privacy and also electric lighting remained similar across the groups. the ones who are using the traditional offices and the ones who are using the modern offices. They also showed higher satisfaction in functional outcomes like collaboration, focus, work efficiency, and job satisfaction, but no difference were found in emotional and motivational factors, including engagement and also team connection. Here you can also see this heat map that categorize their behavior in terms of like me, we, and us environment. So the work hub use was dominated by collaborative, almost like 46% of the users, and 38% by communal users activities, and 15% by individual focus work. And here is also basically the way that people are using the work hub. So occupancy was highly uneven, as you can see through these different colors. Over half of the zone were empty during the observation, which was like 51% of the spaces. And usage was concentrated in reservable spaces, areas I and C, these like very dark blue colors, which consistently showed the highest density and demand. And on the other hand, open and non-reservable areas were largely underutilized, indicating that centralized use pattern drawn by technology supported and also reservable collaboration spaces rather than just, flexibility or different IEQ variables. And another finding of this study was that IEQ variables that we conducted another test, I haven't included that here, it hadn't any significant impact the way that people are using different zones of the work hub. All right, I think that's all I have for today. I also wanted to say thank to all of our collaborators during these different projects. You can see some of the collaborators in this slide. So shout out to them. And thank you so much, everyone, for your attention. So I would like to open this up to question and A. Should I stop recording or?